and then they make two pair, and they make two pairs. So you have really thousands and thousands and thousands of very tiny pairs, all following the same wires and manufacturing small devices, machinery and otherwise. That's one way that's been suggested. That was probably not a very practical way. People had tried a little bit, but it didn't go very far. But how about using this scheme? How? It's all solid. Well, why does it have to be all solid? Why can't we do the same layer scheme and put in a piece, I'm not going to go into the details of laying down the different layers, but it's the same idea. You have the silicon, and then you have some other substance, perhaps not silicon oxide this time. Let's say a substance we'll call blue, of this shape, let's say. There's no harm in manufacturing. There's a piece of silicon in here. I guess I should fill out the blue, this piece of silicon in here. And perhaps, just to make it interesting, silicon dioxide. I called this brown last time, so to keep the things more or less similar. Other substances here, insulators or conductors. And other layers. Let's simplify it. You can make all kinds of things, but something like that. And then there's the blue material here. But the blue material is a substance that's easily dissolved away, but not the brown. And if you dissolve away, that's a loose piece. Okay? Now, these things are electrical. They have all kinds of wiring. You can bring electrical voltages and stuff all over these devices by using the other technique. So you could put electrical voltages on the sides and move this back and forth with an electrical charge. So you can move things around. Now, we've never done anything like that, but it's possible to make devices in which we have loose pieces. That's another way of making. That's a very simple, elementary fact that we can move one piece. You say, that's nothing. Yeah, no, it's nothing, but with a little more imagination, you put a sequence of pieces or a sequence of pole and move it in succession from place to place and carry objects over the surface of the silicon, like cars and so on. It's kind of fun. I haven't got the time to follow the amusing time I had working on all these things, but you can start out and find out that you can move things about with electrical devices and so forth. And therefore, the second way of manufacturing small machines would be the evaporate and etch, freeing pieces of object, etc. You remove them with electrical forces, for example. And what would the uses be? I told you I wasn't going to consider it, but just for fun, the first use of this thing would be to make an optical shutter. You could have this thing over a hole, and when you move it, the hole opens. They're very, very tiny, and they're all over an area. That's a light control. You make pictures because you have electrical control of which ones you open and which ones you shut. You say, oh, we can already make pictures, but we can make very powerful pictures. That is, TV pictures are projected only in a small box. A big projection is rather poor because you can shine the light and it's kind of too weak for fluorescent screens. But you can shine a strong light directly through this thing because there's nothing but shutters and open them and close them in different places and make pictures move and so on with electrical control. Sir?
What I'm confused about is you said that something can only be magnified to 2,000 times and then
optically, with optics.
And then problem. If you could reduce the light, as you're talking about small shutters or small cameras, would it be possible then?
No, you can't make light any smaller than the size of the wavelength of light. These pictures that I showed you were with an electron microscope, which can go to a smaller scale. I'm back here at the scale 2000. I should have been more clear. It's much smaller than any machine has ever been made, let me assure you already, very much. But this would still be at the scale of light, and it would open and close holes that light could go through. Yes. I'm not talking about making it smaller than that. I mean, we haven't done anything like that.
Magnetizer, make it a generator?
You could think of doing things like that, yes. The question is other uses of the stuff. I've thought of a few things. The present way of manufacturing these things and putting different substances in different places is a long and tedious thing. The workmanship needed to get those second pictures to be at the right place relative to the first ones and so on. It's a hell of a job. Suppose instead we could squirt the stuff where we wanted it. How? By having a big flat framework with a whole lot of nozzles with movable holes with the chemicals coming through. But you have to have a valve. You have to move something. So we make it out of this kind of stuff once, you see. Then we bring it and go, and now we have all of the stuff in the right place. Then, of course, there's no limit on the scale. Light is not involved anymore, and we can gradually make things smaller. So there's another direction. Another thing is to imitate a large number of important chemical reactions and biological reactions we have membranes with special enzymes or special molecules in special places. They act like special catalysts. They control reactions very delicately, the kind of delicate control that's in the human body or in any living thing. And these controls, we're beginning to understand how they're made. They're layers of membrane in which these protein molecules have been set in certain particular places. But the scale is so tiny compared to where we are, and we can't think to manufacture them directly and put the stuff exactly where we want. We maybe try by putting something, and maybe it lands in the right place, and by some technique or other, we can make a membrane or another about right. But we can't make all the variety and all the different possibilities for different types of reactions by simply placing the enzymes into the layers where we want them. Oh, we need tools. We need tiny tools to push things around, to make things go. As a matter of fact, if you went to the full limit, we wouldn't need chemists anymore. All that a chemist does is make a new molecule with a different arrangement of atoms. So if you went down to a smaller enough scale, you just put the atoms down where you want them to make the molecule. No hocus pocus with bottles and colored liquids. Actually, that's really magical how they do that. Well, other things have been thought of, the question of making a piece of machinery not that's connected like this in a hole, but a free, swimming, mechanical thing, you see. Naturally, the first application for things, just like it was for computers that would be most popular, would be games. And the game this time is that you have this little thing that goes, you have a control from the outside, it's electrically sensitive, and you can, or send it signals. And it has a kind of sword, you see, and it fights paramecia. You watch under the microscope, and you have this thing, and you control it, and you're fighting the paramecia, see, with your little device. A friend of mine named Al Hibbs suggested